How's it going, everyone? Welcome to this interesting series that I'm trialing out, which is going to be answering some of your questions in the industrial automation and manufacturing space. And so today I wanted to pick the top 5 questions from a couple of different mediums that I'm at least subscribed to and read on a regular basis. Of course, I do have a presence on LinkedIn, I have a presence on YouTube, but I also follow a couple of different forums as well as some subreddits in the industrial automation space. So today we're going to be answering, as I said, the questions. We're going to be looking at some of those references, and ultimately I will be providing you with some feedback based on my personal experience. The first question comes from the user name RavSControls, and he is saying PLC ladder logic simulator and learning platform, free, no ads, feedback welcome. Longtime lurker, infrequent poster here at r/PLC. Recently I decided to take the time to create the PLC learning platform that I always wish existed. The initial version is finally in a state where I am pleased to share it with this community. It has two main parts: a ladder logic simulator with practice problems and learning modules with embedded ladder logic so you can run, plus build it yourself sections to create logic as you go. So he also left a couple of links. We're going to click on the first one. I've already looked at the website just to get a general feel. Here we are on the website. It has a very vibe coded feel look. If you have spent some time using either Claude Code, Gemini, or any of the other LLMs to create a website, it will have a very similar UI. And that's not to say that this is probably the main use case. What is important is that the simulator for PLC actually works. So if we switch over to the simulator, we will be presented with a designer for some of our logic. And I very briefly played around and I built a simple rung. So we're going to attempt to recreate that here as well. So one of the simplest challenges that I often teach in a PLC class is going to be a motor starter. Here we have a normally open contact, then we have a normally closed contact for the stop push button. We then have a coil, which is going to be our motor. So here I'm going to tag and type in motor running. Again, maybe it's not going to let us have a space. It looks like it does. Here I'm going to have the start push button, and of course we're going to have the stop push button. So stop push button, press on apply. We do need a branch around the start, which is going to also have a normally closed. Let's see here. It's very interesting the way it's set up, and of course we can make changes, we can add, remove. It's a different feel than you would get from the general PLC IDEs that I've at least worked with, but we're going to keep working on this rung and double check what it looks like. I can also split to an HMI view here at the bottom, and I'm going to create the two buttons that I've just described. So let's see here. And again, at first it's a little bit clunky, but of course, as you spend a little bit of time with the actual interface, it's actually better than I thought would be possible, at least at this stage. So we're going to create the start and stop push buttons. So here I'm going to change the color to red. And what you will notice is, of course, we will get the running symbol quite easily. So if I press on start, you will notice that the motor is going to start, and then it's going to latch it in using this branch around the start push button, which is checking on the status of the motor. If I press the stop push button, you will also notice that the motor does de-energize the tag bit. So we do have the 3 tags that we instantiated. This is actually pretty good. So I'm assuming that there's going to be some practice problems that you can bring in. Let's see here, select problem, motor start stop circuit. So that's exactly what we've built. I guess you can have a nicer HMI and you can probably design it. So here, I don't know if I can collapse this. We can build the rungs again for a motor start and stop circuit. And in this case, as you can see, we can probably, let's see here in the description, reuse. So there you go. They're pretty much doing the exact same thing that I've just built. I didn't know that there was a practice problem section until I read the prompt from the user. But as you can see, we can fill the tank. We can work with some conveyors. This is actually nicer than I thought we would see from some of these platforms. Again, I'm not sure that this is a full representation of what you would see with an actual PLC when it comes to more complex challenges, but you can definitely, as you can see here on the right, I'm scrolling through some of the objects. You can move, you can add, you can subtract, so the generally available instructions are going to be there. So my general feedback is I think this is neat. I think that you can definitely learn the basics, and I'm hoping that there's going to be nicer and nicer UIs as well as opportunities when it comes to LLMs designing these kinds of solutions. The next question reads as follows: 40-year-old dad switching to trades, automation technology, smart move or too late? Hey everyone, I'm a 40-year-old dad of two. I've been working in retail for 17 years, and I also work as a public transportation driver on the side. Between both jobs, I'm putting in about 15 hours a day. Recently, I woke up and realized I want to make a change. I've been thinking about going into the trade, so I checked out programs at my local community college. I found some that are covered by the Pell Grant, and I decided to go with automation technology. I start in 2 weeks. Do you think this is a smart move given my age and situation? I'd appreciate honest feedback, good or bad. Thanks in advance. And of course, there's already a lot of different comments as to the results of this transition. My personal opinion is that it's never too late to learn the technical side. However, you need to be realistic with your goals and expectations. If you are working 15 hours a day and you're going to start going to a community college on a, I'm assuming, part-time basis while also raising two kids and probably have very little free time outside of family, then number one, you're probably going to take a little bit longer than a 20-year-old going through the same program. It's probably going to be a little bit, I would say, more difficult to learn some of the concepts at this stage when you have no previous background and you probably do not recall a lot of the fundamentals that you had to learn in high school, like math and physics. Again, nothing extremely complex, but ultimately there is a foundation that is still fresh in the mind of someone that is going to go to the program at an earlier stage. That being said, there's a lot of jobs in the industrial automation sector in a very general sense. Every single facility that I go to, at least, has openings for technicians, electricians, mechanics, engineers in different disciplines. So I don't think this is time wasted. I do believe that there will be a lot of security in these jobs going into the future. So I think that no education that is put in yourself is going to waste. At the worst case scenario, you will spend some time studying. You will hopefully learn a lot of different skills that will be applicable to your current or future work, and you will ultimately train your mind to stay relevant in this day and age. So I absolutely think that it is possible to make the switch. The question becomes, how bad do you actually want this while having so many other commitments at this specific age? Hi, my name is Vladimir Romanov. I am the founder of Joltek as well as Solus PLC. With a background in electrical engineering and MBA, and over a decade of experience leading projects in manufacturing and industrial automation, I help engineers, managers, and manufacturers make smarter technical and business decisions, modernize their operations, and build stronger careers. If you're serious about manufacturing, automation, and staying ahead in the industry, subscribe and join the community. The next question we have is about PLC trainers. I've been in this space for a very long time. I have built my own PLC trainers. You have seen me put an entire box, a Pelican case of a PLC trainer together. I now have multiple videos on this channel where I discuss PLC trainers and ultimately what my approach is when it comes to designing and building them, but also utilizing them in actual classrooms. So someone here has made a post on PLC trainers. Old school trainers used to be plastic boxes that would mount in the rack, have switches, BCD displays, analogs, very compact and small. Has anyone found like printed plastic blanks that can mount to din rail and be populated in the same fashion? I need to make some trainers. One that is not brand specific would be best. Ideally compact like the old ones too. So my general perspective is that there is not a lot of value in actual LEDs or lights, as well as push buttons and switches, outside of maybe the first half an hour, maybe a couple of hours, when you're just getting used to PLC wiring. So usually when you're going to be taking a PLC class, and just as we saw in the earlier answer to a question of a simulator, there's not a whole lot you can do with a set of push buttons and a set of lights and switches. Once you have gone past the very basic instructions, everything needs to be simulated. And the reason for that is, of course, as you start looking at PID type of applications, as you're starting to look at more complex machinery, it becomes very difficult and impractical, in my opinion, to simulate with basic lights and switches. The second argument, of course, is you can virtualize almost everything nowadays, and you can use a variety of different free tools. You can use inductive automations, ignition, you can use Node-RED, you can simply latch bits on and off inside of your PLC IDEs. It is available in every IDE that I know of, so there's very little value in going and toggling a special switch when you can just toggle that bit inside of your logic and get effectively the same exact result, depending, of course, on how your rungs are laid out. So my general comment is you can absolutely build a PLC trainer that has some of these elements. You can purchase them on AliExpress, you can purchase them on Amazon in bulk. They are pennies on the dollar, very inexpensive electronics nowadays, but again, it doesn't add a whole lot of value. Do I know of specific trainers that provide this? There are multiple manufacturers of PLC trainers in our industry, from very inexpensive consumer grade trainers to very expensive training modules that you would purchase for a university and or school. And of course, my general recommendation is to go to one of them because they've already solved this problem and you can purchase a pre-built trainer. The next question that we have comes from a user name that I will not read in this comment section, but he said, I built a browser-based IEC 611313 PLC engineering environment looking for people to tear it apart. Hey, our PLC, I've spent the last while building a fully browser-based PLC programming environment. What it actually does right now, all 5 languages, OPC UA and Modbus connectivity, live tag monitoring, and rung energization in online mode, HMI designer built in, multi-user with role-based access. Version history and snapshot restore runs entirely in the browser. I know this community will find holes in it faster than anyone else, which is exactly why I'm posting here. If you want to try it, comment or DM me and I will give you free access. Happy to answer any technical questions in the comments. So my first question is, why would you be building this? Again, I think that everyone has been trying to build a virtual PLC programming environment for a very long period of time. I think that the LLMs, as we've seen a little bit earlier, have certainly unlocked the possibility of creating basic ladder logic relatively easily inside of a web-based environment. So now you can generate ladder, you can generate function blocks, you can generate structured text, sequential flowcharts, and ultimately it seems a nice to have. I have not seen him post the actual link anywhere as well as in the comments. So to me, it seems that it is a problem that doesn't necessarily exist. If you're building in Rockwell, you will likely use the Rockwell IDE because it will be difficult for you to export whichever file, number one, this is going to create into Studio or RS Logic 5000, but also it will probably not have, and this is just my guess here, it's not going to have the complex functions that you would expect side of a normal PLC IDE. And of course, again, I would assume that this also cannot interface with all the modules. So when we talk about PLC programming, it is not just contained, and it is not just about the PLC. It is also about the peripherals. It is about the variable frequency drives, or VFDs. It is about the servo drives. It is about load scales coming in from third parties that need to pass data. And although he said that there is Modbus connectivity inside of the Rockwell IDE versus a Siemens IDE versus CODESYS, you're going to have very different ways of setting up that connector. So I'm not sure how much value you would get out of building it inside of this web tool and then trying to export that into whichever language you want to use for your specific system. So I might be wrong on this, but again, I am not sure that this is going to solve a problem for me or for any experienced control systems architect out there. But we will definitely have to get a link at some point and see if we can play around with this tool. The last question we have is interesting. This is a philosophical perspective. The user by the name of Himanishu Creative is asking, are PLC projects getting more complex, or does it just feel that way? And it feels like modern automation projects involve way more layers than before: HMIs, networking, remote access, databases, analytics, etc. Sometimes the PLC logic itself seems like it's the easy part now. Curious if others are feeling the same shift. I've been saying this for many years only because I have been very involved in data projects for a variety of different manufacturers that I have done a lot of the systems integration work for. So nowadays, as a control systems engineer, control systems manager, or even director of automation, it is no longer sufficient to simply put the system in place and allow it to run. There is an expectation of some of the items that he has mentioned in this post. There is an expectation that there is an integration of a higher level SCADA system on top of just the local, let's say, HMI design. There is an expectation, therefore, as we build out some of these SCADA systems, that there is network connectivity, which then entails usually the OT team needing to configure not only plant level switches, not only the sort of the underlying layer of the OT side, but also sometimes going that extra mile and making sure that the plant connectivity is established, which means knowing the different protocols, at the very least setting up IP addresses, subnet mask, default gateways, but also assigning VLANs using NAT protocols, and some of the other networking fundamentals that we have discussed on this channel. I definitely agree that this is something that we're seeing more and more of. Remote access, again, I think that since COVID, we have simply accelerated the adoption and the ability or the expectation that there is remote access to the different assets as well as the site in various capacities and for different groups. So for someone that's commissioning the machine, that might be monitoring the machine for a period of time after it has been left on the plant floor. For an engineer that works at a plant, it might be the expectation to remote in the evening or during the night if there is a catastrophic failure of equipment, to troubleshoot remotely while speaking to a local tech engineer or electrician. Databases and analytics, again, it is a big part of my work and the engagements that I have been pushing forward, because there is an expectation of improving reliability, improving performance, and ultimately measuring some of the KPIs of your plant-based systems. It is no longer sufficient, I would argue, to simply run the equipment. It is now a necessity to understand how well it is running, how well it is improving as a result of investments into that specific equipment production line or area, and what are some of the capabilities that we can meet or exceed when it comes to selling out the product that we are actually manufacturing. And of course, there is a general sense that if you are on the OT side, that in addition to knowing PLC programming and HMI development, you need to be learning some of those smaller concepts or other concepts that have not been previously related to the job. And I think that once again, I've made this comment a little bit earlier, since COVID, that expectation has just been accelerated. So it is normal to feel that way. I don't think that there is any how would I best put it? There is not necessarily less of a necessity of control systems programming. There is now just an extra layer of need of taking care of some of those other concerns. So if you've enjoyed this commentary and basically breakdown of some of these questions that have been the most popular in this specific medium, don't hesitate to let me know if you have other questions that you would answer it, if you have other places that I should be looking for questions. I'm obviously, as I've mentioned a little bit earlier, active in a few different communities. But if you have something that requires my attention, you will answer, don't hesitate to reach out. The best place to reach for me would be on LinkedIn. If you have any questions around projects or client work in the industrial automation or manufacturing space, don't hesitate to reach out as well. Happy to have those conversations, and I will see you next week.